Okay, so hello and welcome everyone to our Teaching Eco-Design with LCA webinar. Today we're going to talk about how life cycle assessment can be effectively integrated into eco-design education. My name is Linda, actually not Natalie Miller, that's kind of a mistake. But yeah, I'm a product marketing manager at IPOINT. And before we officially start today's webinar, I'm going to quickly give you some general info on what this webinar will look like. The webinar will approximately last 45 minutes. It will be recorded and sent to you afterwards if you want to rewatch it. Everyone else but the speakers are muted, so if you have any questions, please put them in the chat because we will have a Q&A session at the very end of the webinar. Taking a quick look at our agenda today, in just a minute I'm giving you a quick intro on IPOINT in case you're new to us or you need a quick reminder on what it is exactly that we're doing. Then I'm going to hand over to my colleague Maulana Ajie. He is a sustainability consultant and LCA specialist at IPOINT. He's also an adjunct lecturer in EcoDesign and material energy flow analysis at SRH University of Applied Sciences. After that, Hendrik Lambrecht will take over, and he is a professor of industrial ecology and quantitative methods at Pforzheim University of Applied Sciences. He will talk about Umberto in teaching and education. Following that, like I said, we have some time to answer your guys' questions if you have any. So yeah, before we dive into today's topics, like I said, let me give you a quick introduction to IPOINT. IPOINT is a leading provider of digital solutions for product compliance, sustainability, and circular economy. Our mission is to empower companies to make informed, sustainable decisions across the entire product lifecycle, and that with data-driven, transparent, and efficient tools. One of the key solutions in our product portfolio is Umberto, our lifecycle assessment software. Umberto helps companies analyze and optimize environmental impacts, from calculating PCFs to conducting complex system-level LCAs. Some of you might remember IFO Hamburg, which is the original developer of Umberto. In case there's any confusion, IPOINT and IFO actually joined forces back in 2017, and with that, combining deep LCA expertise with innovative technology. So that synergy is a big part of what we're sharing with you today. So yeah, stay tuned. And that's it from my side. Now I'm happy to hand over to Maulana. I think we can't hear you, or is it just me? We just practiced it, but now that we're live, I guess it's just gonna take a minute.
I will directly check my mic. Does it work?
For you it works. So. Okay. If it's not working, just ditch the headphones, I'd say. No.
Now, hello?
Ah, yes. Now it works.
We just tested 15 minutes ago. Quite strange, but yeah. Still in the learning phase. So yeah, thanks, Linda, for the introduction. If you can just quickly go to the next slide. So yeah, warm afternoon, everyone. My name is Maulana. So I'm a LCA specialist at IPOINT, a sustainability consultant, and also an adjunct lecturer in eco-design and material energy flow analysis. So I mostly work content-wise on electronics and information communication technologies, but with respect to LCA methodology, I also go a bit on prospective LCAs, input-output tables, and ecosystem services. So next slide. Yeah, next. Okay, so yeah, EcoDesign. So yeah, some of you might have heard of the term EcoDesign and might ask also what's the difference between EcoDesign and LCA. So to put it short, EcoDesign is the approach, LCA is the tool. At the end of the day, the goal is the same, right? So we want to reduce carbon and material footprint in our daily lives. And what's important, I think, when we talk about eco-design is that it goes sort of beyond high-level reporting. It's not only about multiplying a material flow with an emission factor. It goes into detail of your products. It looks first also at different hotspots involved and the trade-offs involved there. So for instance, through certain decisions, you might reduce your carbon footprint, but with electronics, for instance, you might increase ecotoxicity. It's also important to understand with eco-design that we are talking about functionality, that we want more functionality, but with less materials. And we are looking for alternatives because perhaps in the past, when we talk about eco-design, it has been focused on a product in which the product is an object, but the concept of the product itself has changed, right, throughout time. So I live in Munich, and more recently there was the IAA Mobility Conference, so a big conference on mobility. And here, even the object of a car, by the definition, you might say has changed. You might even argue that a car today is more like a big computer on wheels, so to say. It's more electronics and less of a car. So yeah, on the one hand, this concept of a product has changed, but also we go beyond the product and look at the function, meaning at the end of the day, we want mobility, right? And if you can go to the next slide. One aspect of eco-design, for instance, which I bring to the class that I teach is that, for instance, when we talk about function, it means not only calculating the impact of one product, but what we get at the end of its use. And this doesn't always mean that we are buying a new product, but we might use, for instance, a leased product or a refurbished product, because at the end of the day, we don't want to quantify a piece of laptop, for instance, but we want to quantify the use of laptop for working. And this means then that we don't always need to buy a new laptop, but we can use a refurbed laptop, a leased laptop, or a repaired laptop. And in this regard, in teaching these concepts which go, let's say, beyond the traditional or the old understanding of eco-design, one would need then a tool which is quite flexible, to not only look at objects or quantify objects, but also look at new approaches or business models. And next. So where I teach is at the University of Applied Sciences. And for those in the international audience who are not familiar, perhaps, in Germany, we have two types of higher education institutions. So one is the university, and the other is the University of Applied Science. And by definition, it's applied. And that means we go less into LCA methodology. For instance, we don't focus on developing new methods to quantify microplastic, for example, at least where I am, but more in this hands-on modeling, looking at case-by-case examples, real-world examples, And there, I think it's also important for the students to look at cases that they are interested in, right? So for instance, I had the case where the student was interested in modeling single-use sandals used on the beach, for instance. And based on that, based on this hands-on approach, you would also need a tool where it's easy to understand or to link, let's say, the theoretical concepts of LCA with modeling. So if you can go to the next slide. And yeah, with this, one example of a tool, of course, is Umberto. And you can see from the diagram, it has a very strong visual interface. And especially as I teach bachelor students, so really, even one course is, I think, second semester, so really students fresh out of high school, fresh into this world of higher education. You need something very visual, very easy to understand. When you want to model LCAs or eco-design approaches. And with Umberto, you see this input and output logic when we model a certain product or a service where it starts from the beginning, so raw material extraction until its disposal. But beyond that, so beyond this very strong visual interface, this input-output flow logic, I also like the fact that it sort of compartmentalizes different concepts. So on the one hand, you have the actual visual model. On the other hand, you have a feature where you can see the mapping of flows to secondary data sets. And the third part is this concept of production order, which might be somewhat new in the world of lifecycle assessments, because with this approach, the idea is that the model would be your kitchen, so to say, and the production order is the recipe, which means you only need to model your kitchen once, and then you can basically change the recipe. So for instance, if I wanted to model a headset based with animal leather, the whole production line would be a headset production line, but then the production order can be replaced with a headset from pineapple leather, for example, or another product in which the actual ear cushions for the headset is not 10 grams, but 20 grams. So this idea is to have a more generic approach to modeling, where everything is not thrown into the model, where the model with its size is not too large, but you have sort of a template, and then this can be reused for multiple calculations. And next. And that goes a bit more towards the new expectations when it comes to doing LCAs. So perhaps in the past, the expectation was to create a very detailed report, 70, 100 page long, which would take 6 months to make. But the times have changed, and companies are looking more and more towards rapid assessments. They want to calculate more products in less time, which can be third-party verified, which then can be sort of forwarded to other platforms like the digital product passports. And they want to collect their data with automated data pipelines. And of course, if we go back to my experience, you might not be expected to teach all of this to a bachelor student in their second semester to develop this whole, let's say, automated workflow of calculating multiple products instantly. Nevertheless, this generic approach, which I explained earlier, which is available in Umberto, is, let's say, a first step into this logic of more rapid assessments, of more assessments at scale, if you will, because yeah, this is, I think, the expectation of the era that we are living in currently. And yeah, with that, I would like to then conclude my part and hand over the moderation to Linda.
Handing over to Hendrik.
Okay, so switch on the mic, and then as I asked Linda to share my own slides, I have to do this. Yeah, do you already see my slides, Linda? Can I ask you?
No, not yet.
Not yet, okay, but now.
Yes.
Fine. So hello and welcome also from my part to everybody. Thank you also, Linda, for your introduction. Yes, in this part I want to shed a light on the question of how we can use Umberto specifically in teaching and education. And actually, like Maulana, I'm working at the University of Applied Sciences. But I would say that even though this is applied, we are nevertheless looking also into the theoretical details of life cycle assessment. We have a master study program, life cycle and sustainability, and also a bachelor program. And I think I agree fully with Maulana that times are changing and that there are new expectations, but I think it's still crucial and very important to understand what is happening in LCA. If we are talking about product development, for example, it's important to really understand, are things real? Are they only artifacts? So even though we need to become faster and more efficient, we need still to understand. And this is actually the reason why I'm still preferring to work with Umberto when I'm teaching LCA, and this is what I want to talk about a little bit. So the agenda, as you can see, is I want to explain to you why I think that Umberto is particularly well suited for teaching in the LCA field. Actually, we are having a lot of discussions among colleagues because there have been several tools on the market ever since, and there are new tools coming into the field nearly every day. So the question is sometimes, why are we still working with Umberto? And I want to share those thoughts a little bit with you. Then, yeah, what are the learning objectives that we see and why we are using Umberto in the end? And then I want to sketch or give you a rough outline of how a typical introductory course will or could look like, or usually looks like, actually. So for me, the most important thing is that distinguishes Umberto from other softwares is that it's what I would call a two-stage modeling approach. We have on a first level, if you like, the material flow perspective. Actually, as I was introduced, I'm doing industrial ecology, and I'm coming from this direction. So first of all, we are looking at the system as it is, I would say. So we're taking this material flow perspective. And then in a second level, we are adding on this the accounting perspective, I would call it. That is, more specifically, if we're talking about LCA, we attribute the impacts to specific products. And this two stages allow us first to be more flexible in the modeling approach. This is what Maulana already introduced. So for example, we can use those product orders or bills of materials to specify the system. We can also use those basic models to do, for example, system optimization, what you can't do if you are starting with the LCA model, actually. And well, if we want to go in the direction of LCA, we can then do this next step and do this, this attribution, the second step. But there are also other methods to evaluate such a material flow model. For example, material flow cost accounting, which is as well possible. So as you can already see at this point, it's a quite flexible approach. So I want to have you back in your mind that there are those two levels, the material flow basis and then the accounting extension, among which there could be LCA. Now, how does this look like concretely. So if we start with modeling, we are starting by simply drawing a flowchart with processes and places. And as you can see here on the right-hand side, it's a quite simple example I would use in teaching. For example, it's a package for noodles made of polypropylene. So we have here the raw materials, manufacture phase, use phase, and in the end, a disposal. It's a very simple model with just 3 processes in the foreground, and then those places here are basically the interface to the underlying LCA database. But to mention this, the model can be more complex. We can use nonlinear specifications of processes. I haven't here any nonlinear specification in this model, in this example, but you can do this. Or you can also have places which act as storages, so where you can have differences in stocks, which might be useful if you are modeling real production systems. So not directly heading towards LCA, but starting by modeling a production system. So if we are on this level, the material flow level, we are looking at material energy flows, also flows of services as input output, right? So this here means that we have some material going into this process, and we have some material leaving on the other side towards the incineration plant in this example. First, small excursus on this linearity issue. So in general, impacts and revenues or functions of processes need not to be linear, of course. They can have any form, as you can see here. And depending on which part I'm here in this real curve, I will have very different specific impacts, actually. What we do when we do LCA is that we go to a specific point of such a system, we look at the impact that is connected to a certain revenue, and then we linearize. So we do this straight line here. And of course, the straight line depends on which part of this curve we are starting. And Umberto actually gives you both possibilities. So on the material flow basis, you will model the system like this, very flexible. And only if you go to the LCA part, then you will do this linearization. So these are 2 separated steps in the software. Then there is a second very important point when you are switching from the material flow to the LCA stage. As I told you, in the material flow basis, we are looking at those material flows as input-output. Now, if we come to LCA, we have to evaluate those material flows in a very basic manner. And this is what you, if you have already worked with Umberto, know that you have to define that different materials have the basic property of being goods or bads. So this is the way you can distinguish between some raw materials, for example, on this side, and wastes on the other side. Now, if you have materials which are wastes, which are actually bads in the wording of Umberto, then what happens is, if you go to the LCA perspective, that they change the direction. And this change of direction, you can see here, right? We have the arrows from the use phase to the incineration plant. And if you're changing to LCA, if you're changing to the accounting perspective, you will have an arrow in the other way around, which makes sense because the impact of the incineration is attributed to the use phase and to the functional unit in the end, right? But these are 2 different levels, actually. So in the LCA perspective, we have this attribution of impacts to products. If we have a look at another LCA software, I take here Brightway with the activity browser as an example. And what you see here is actually the exactly same system. Then, you know, this distinction between a real-world system and LCA accounting perspective is not so clear. So in general, we have those, what I would call blurred boundaries between foreground and background. So you start with your noodle package, and well, there are some processes that you define yourself. There are others you take from the database, and you know it's really a very fluid transition between those 2 systems. And from a teaching perspective, I find it useful to make a clear distinction here. The other point that I already elaborated on is this differentiation between material and accounting perspective, you lose it completely. If you're using other LCA software, you're always starting directly with the accounting perspective. As you can see here, for example, waste is an input. It looks like an input to our Moodle package, which from this material flow perspective and also the intuitive perspective, many beginners in the field, is really strange. Why is waste an input? It's an output, no? So you don't see this basic thing with goods and bads here, you're just using it. And then there are sometimes strange things that happen. For example, you have in those softwares negative signs, which should take into account this good and bad property, but they are not doing it explicitly. And so it's, in most cases for students, it's rather confusing. And there are other things. If I'm modeling a system in the material flow perspective, I will have transports as processes, and the function of a process is, of course, to transport some object from A to B. If I'm using LCA software or the LCA logic, I'm considering transport as services, which also are inputs in those processes, just like the waste, which if I'm used to LCA is completely okay, but it's anyway, from the first start, it's a little confusing sometimes. So just to say one more, I think it's useful for beginners, particularly, to start with this material flow perspective and then to switch consciously to the other perspective instead of, you know, stepping directly into this LCA way of looking at the world. So what are the benefits for students or the learning objectives I pursue with my LCA courses using Umberto? Well, the most important point for me is I want really to understand the students or know the relation between LCA, which is an accounting perspective, and reality. Of course, the material flow model is not real as well. It's still a model, but I think it's a step in between. So as we have seen, it's not the world that is linear, but it's the attributional approach to LCA which makes it linear. And you can understand this from this distinction between the two levels. And it offers also the possibility to have a consistent transition between an organizational view, where I'm, for example, modeling a whole production system, and the product view that we know from ISO LCA. Then we have still, because we have this good-bad formalism in Umberto, a very methodological, sound treatment of multifunctionality. We just have processes with several revenues or reference flows. We have this graphical and very intuitive way of just starting our models by drawing the system flow chart. And yeah, one more point, we have this clear distinction between foreground and background system, where students in particular are forced to do a very conscious transition from the one to the other systems, which still, I believe, is quite useful in teaching in particular. And just to show this to you with this second excursus, we have two different ways to actually integrate or model background data. What we can do, and what I usually do as a first step, is we have, as I already said, these places as interfaces. For example, here we have the raw material which is produced, or here we have the treatment of the wastes. And well, these are the points where we connect to the background database. And we can do this in Umberto by using so-called mappings. So I have a material which I defined myself, for example, the polypropylene granulat. And then I'm doing this connection, this explicit connection to an exchange in this case, EcoInvent, by doing this mapping. And so I connect my material to the material of the background database using, of course, all the information which is included here. But once more, for me, it's about doing this consciously and not just somehow. But sometimes I always also want to know what happens in the background. So of course, I can also integrate information from the background system in my model. This is when I'm using, for example, the expand function of Umberto. As you can see here, I can, so to say, take processes from the background and take them in my foreground model. This is what happens here. So here I have explicit modeling of the production of the raw material or the waste incineration. Okay. To slowly come to an end, I will show to you here the typical outline of an introductory course I would do in LCA, as I already said, using Umberto. The first step is, of course, to model a simple foreground system, for example, something like a PET bottle, but very often I also taking examples that the students find interesting. Then the next step is to connect those foreground models to the background database, and there are several different possibilities. I already mentioned this mapping. I can have a direct connection to the database, integrating exchanges from this database. I can have process specifications from the database, or quite different possibilities. And it's about actually to the students to learn this and to know the differences. Then usually I'm looking at some special aspects of LCA modeling, which is recycling. It's already always an issue. And also from a methodical point of view, if I'm doing closed loop recycling in Umberto, it's not so straightforward. So this is something we are looking into details, or we are treating multifunctionality and allocation. And in the end, of course, it's very important to do also the result analysis. And there we can both use Umberto and the, well, let's say simple analysis functionalities Umberto provides, but we can also use the export of LCA data and then use methods from, for example, the pivot charts of Excel to have a more thorough data analysis. So Umberto is simply great, everything perfect. Well, yes, nearly. There are just 2 points I want to mention here. Of course, there are sometimes things which could be easier in the handling. And actually, I'm a really Umberto veteran, so I'm working with this for 20 years, I think, and I actually knew every version of Umberto which was out there. And there were some things that already worked better in the past. So here's my list. I won't go into the detail, but it's small things. It's not really a big deal. But if I had a wish, those would be some points. And one thing that I find is really important is that we need actually better interfaces between Umberto and other LCA softwares. I think this would be, for teaching, but also for research, be a very important thing. For example, I mentioned Brightway. And even though I think that from the modeling perspective, Umberto is really, in some regards, better than Brightway, there are other points, if it comes to background analysis, where I personally prefer Brightway. So I would really like to have there a better interface between those two softwares, but between others as well. I think this would be quite useful also for the students once they come from the studies to let's say real life work and use other softwares as well. Okay, so from my part also, thank you for your interest this afternoon. And well, if there are any questions, please feel free to use the chat, or yeah, and here I give back to Linda to manage all that.
Thank you. Yeah, thank you for these insights. I think it's always very valuable to hear from people actually using and actually teaching Umberto. So yeah, that was really interesting. And like you said, now's the time to ask questions. So if you have any, please put them in the chat. And we still have some time to answer them. I think there's one question still there already there, but I think that's more like a personal, like a request, and we'll definitely get back to you on that. But I think that's right now, that's not the space for it. But yeah, if you have any questions on whatever Hendrik and Maulana just talked about, please feel free to let us know. if you come up later with any questions, you can definitely also still contact us or our speakers, and we'll get back to you. So I'm just gonna wait a few minutes in case anyone's like thinking about something. But I think you guys made your points points very clear. I think there's no questions there. In case I'm overseeing something, but I don't think so. Okay, so like I said, feel free to also text us any questions, like contact Hendrik on LinkedIn or Maulana or just our IPOINT account on LinkedIn, and we'll get back to you on those anytime, so that's not a problem at all. Yeah, like I said, we're also gonna be sending you the recording of the webinar. So yeah, you'll receive this within the next few days. So yeah, now a big thank you to our speakers, Hendrik and Maulana. I think it was really, really valuable, really interesting what you talked about. And of course, also a big thank you to everyone who participated, everyone who joined our webinar. Yeah, like I said, if you have any additional questions, feel free to reach out. You can scan the QR codes to our LinkedIn profiles right there. And yeah, have a wonderful rest of your day, and hopefully we'll see you in our next webinar. Bye, everyone.